Welcome to the live stream today. 2nd to 7th graders, 7th grade students will focus on topics that are relevant to you today. Let us know if you have any questions, and appreciate your time, your 1 hour, spending 1 hour with me on Tuesdays, Thursdays, and on Mondays, Wednesdays, and Fridays. I appreciate that time. I look forward to our hour together. Today I'll be introducing some new topics, and hopefully we'll get some participation from you. I know you're usually very good at participating, so I have a few questions, and then towards the end we're going to have some word problems and puzzles at the end of the session. So we'll start the way we're going to do it today, the same way we do it every time. I'm going to put the question out here, and then you have a chance to attempt it for like a minute or so, and then after that I'll show you how to do it. If there are multiple ways to do it, I'll go ahead and show you the different ways you can do it. You can attempt that question. So I have here a question for 2nd to 3rd graders, and this is on ordering fractions. One of the things you will see is that I'm now in addition to adding the grades, I'm also adding the topics, and highlighting the topics by using a red text, so red font, so that you guys can see what topics we're focusing on, and so that if you have any questions along those lines, you can also present them. Okay, so we'll get started with this question. If you have any questions as we proceed, feel free to post the questions on the chat, and I'll be glad to work with you on those questions. And if there are questions that are also relevant to what we're doing that I may not have here, you can also post in the chat, and I'll try to create time to address those questions for you as well. Again, thank you for joining the session today, and let's enjoy the ride. Okay, so we want to order the following fractions from the greatest to the least. The fractions are 2/3, 9/10, 3/4, and 11/12. So let's go ahead and see the order from the greatest to the least. We're going from the greatest to the least, which means from the largest to the smallest fraction. I'll wait for a response or two, and then once we get that, we'll go ahead and show you how to actually work these problems out. Okay. Thank you, Anna. So let's try one more response, and then we'll go ahead and show you how to do this. Remember, in any session that we have, calculators are not allowed. So don't use a calculator. I want you to learn the math behind what we're doing so that you can do them independently and you are not too dependent on a calculator. Just trust me on this, you will appreciate it in the long run. Okay, let's wait for one more response, and then we'll go ahead and get started with the solution. All right, since I'm not getting another response, so let's go ahead and show you how to do this. The first thing you always want to do when you're comparing fractions, it's easiest to compare fractions when they all have the same denominator. So let's go ahead and figure out a way to get the same denominator. Here we have denominators are 3, 10, 4, and 12. With experience, you'll be able to see these denominators and come up with a common denominator. But if you're not sure how to do that, here's the way I like to do it. So I'm going to write each of the numbers. So I have 3, 10, 4, and 12. So I'm going to express each of these. Hello, Lillian. I'm going to express each of these as a product of their prime factors. So this is going to be, we're just going to write 3 here. That's the only prime factor. You have 2 multiplied by 5. 4, you have 2 multiplied by 2. And for 12, I have 2 multiplied by 2 multiplied by 3. So our least common multiple is going to be, we have 2 times 2, because we always pick every prime factor is useful in the least common multiple. We're going to pick out 2 multiplied by 2 because we have 2 adding to it. If you have a question on this, I'll do some examples on this to show you how this is done. So this is 4 multiplied by 3 multiplied by 5. So this is 12 multiplied by 5, which is equal to 60. Okay, so our least common multiple is 60. So we're going to find a way to write each of these numbers here so that the denominator is 60. So let's go ahead and start with 2/3. So 2/3, for me to get 60, I have to multiply 3 by 20. So I'm going to multiply 2 by 20. So this is going to be 40 over 60. Then 9/10, I need to multiply 10 by 6. Also multiply 9 by 6. 9 multiplied by 6 is 54. 10 multiplied by 6 is 60. And then 3 over 4, I'm going to multiply 4 by 15. And here I'm going to multiply 3 by 15. So this will give you 45 over 60. And then 11 over 12. I'm going to multiply 12 by 5. So multiply 11 also by 5. This is going to give you 55 over 60. So now we're going to write this from the greatest to the least. Pay attention to that, from the greatest to the least. So let's look at the greatest. Now we have all of the same denominators. So let's go ahead and look at the greatest. The greatest is 55. So I'm going to write 55 over 60 is the greatest. What comes next is going to be 54 over 60. Next we have 45 over 60. And then finally we have 40 over 60. Now we will now replace each of these fractions with the original fraction equivalent. So 55 over 60 is 11 over 12. 54 over 60 is 9 over 10. 45 over 60 is 3 over 4. And then 40 over 60 is 2 over 3. When you're working through problems like this, please pay attention to the question. A lot of you got the answer in the reverse. You wrote it from the least to the greatest. Be sure to pay attention to the question asking for the greatest to the least. So that's just the reverse. Next question. I'm going to introduce a new concept here, divisibility rules. For most school districts, this starts in the 3rd grade. So, and I know in some other school districts, they deal with this in the 5th grade. So I want you to go ahead and tell me which of these, if these numbers are divisible by 3, 5, and 9. No calculators. I want you to be able to do this without a calculator. I want you to use the divisibility rules. I'm going to write them once we get to working through the questions. Don't use a calculator. Are these numbers divisible by 3, 5, and 9? Let's give you about 30 seconds. 30 more seconds on this. Are these numbers divisible by 3, 5, and 9? You can say yes, yes, or yes, no, or no, yes, or no, no. Whichever one. No, comma, no, yes, comma, yes. and then I'll be able to interpret that. So I'll make sure I can write the rules here. 3, 5, 9. Okay. Do we have any answers yet? Okay, let's go ahead and look at some of, let's start with the rules. Let's state the rules. So if a number can be divided by 3, what that means, okay, what that means is that no for which of the questions or which of the numbers are you saying no for? So if a number is divisible by 3, the sum of the digits can be divided by 3. So if a number is divisible by 3, I have videos on this as well. I have a video just exclusively on showing you all the divisibility rules and how to apply them. So the sum of the digits can be divided by 3, then the number can be divided by 3. For a number to be divisible by 5, the number must end in 0 or 5. And then for 9, if a number is divisible by 9, the sum of the digits can be divided by 9. Okay, so let's take a look at each of them. For the rule for 3, we're going to add each of these digits together. 1 plus 7 is 8. 8 plus 2 is 10. 10 plus 8 is 18. So now I have 18. I can go ahead and then add 1 and 8 is going to be 9. Can you divide 9 by 3? Yes, you can. So 3, this number can be divided by 3. What about 5? The rule for 5 says it must end in 0 or 5. This does not end in 0 or 5, so for 5, I'm going to put an X right here. Then for 9, we already added the digits, and we can see that it's 9. So 9 can be divided by 9, so that's what you have. Then what about 6,840? We're going to add the sum of these digits together. So 6 plus 8 is 14, plus 4 is 18. 18 plus 0 is 18, so 18. 1 plus 8 is 9. So can you divide 6,840 by 3? The question you want to ask is, can you divide 9 by 3? The answer is yes, so that is true. What about 5? A number must end in 0 or 5. It ends in a 0, so you can divide this number by 5. And then the last one is for 9, the sum of the digits can be divided by 9. We already summed up the digits and we have 9. So the answer is here. Are the following numbers divisible by 9? Here is, you can say no here, and then you can say yes here. But this is more specific on how you would want to treat this type of question. I think in the next session we have, I'm going to try to repeat this. This is a topic that, if you understand this topic, it would make a lot of your math so easy, because some of the other questions we're going to be doing have to do with understanding factors. So I think the next one is probably a factor question as well. So now we're going to create factor trees. We're going to create factor trees and use that to express each of these numbers as a product of their prime factors. Remember what a prime factor is? Hello, Dio. A prime factor is a number that has only two. A prime number is a number that has two factors, 1 and itself. And it's important to remember that 1 is not a prime number. 1 is not a prime number. If you can send me some examples, we'll do some of that. That's not a problem, Ini. So express the following numbers as a product of their prime factors. Express the following numbers as a product of their prime factors. We have 72, 84, and 108. To do this, if you're very familiar with your divisibility rules for 2 all the way through 10, this will be easier for you to do. So let me go ahead and show you how to do this actually, because this is something that is important for you to know. Let's see, 72. I'm going to show you how I think about this when I'm working through this. I only want to have prime factors. Here, there are 2 schools of thought. The one I prefer is to just use prime factors and build your tree downward. So 72, because it's an even number, I can divide it by 2. 72 divided by 2, I'm going to get 36. Now I have an even number again, I can divide it by 2. 36 divided by 2, I have 18. This is an even number, I can divide it also by 2. 18 divided by 2, I have 9. And then 9, you can divide it by 3. 9 divided by 3, I have 3. So 72 is going to give me, and then I'm going to go to the leaves right here and pick up the numbers that are on the leaves. So it's going to be 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. Then let's go for 84. Let's go for 84 right here. We have an even number, we divide by 2, we have 42. This is an even number again, we divide by 2, and we have 21. 21 is an odd number, so you can divide by 2. So I'm going to add the numbers together. 2 plus 1 is 3. Can I divide 3 by 3? Yes, so 3 is a factor. 21 divided by 3, I have 7. So now this is going to give me 2 multiplied by 2 multiplied by 3 multiplied by 7. And then 108, 108, even number, divide by 2, we have 54. This is an even number again, we divide by 2, we have 27. Now, we can divide this by 2 because it's an odd number. So let's see, can we try 3? What is the rule for 3? If the sum of the digits can be divided by 3, then the whole number can be divided by 3. 2 plus 7 is 9. We can divide that by 3. So 3. 27 divided by 3, we have 9. And then 9 divided by 3, we have 3. So we're going to pick the leaves again here. So this is going to give us 108. It's going to give us 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 3. Now for 7th graders, you may be able to do this. We can write this as exponents as well. Let me write in a different color. So we have 1, 2, 3 instances of 2. So this is going to be 2 to the power of 3 multiplied by 2 instances of 3, 3 multiplied to the power of 2. Then for this one, we have 2 instances of 2, 2 multiplied by 2, multiplied by 3, multiplied by 7. Yes, we're doing some fractions today. And then for 108, we have 2 instances of 2, 2 multiplied by 2, multiplied by, then we have 3 instances of 3, 3 to the power of 3. So this and this are exactly the same. This and this are exactly the same, and this are exactly the same. Okay, so the next thing we're going to do, let's try the next question. This is for 3rd and 4th graders. A local nonprofit has a budget of $9,724.89 for donations to organizations in the community. It contributed $3,644.80 to a local women's shelter and $5,923.74 to a nonprofit drug treatment center. How much money does the nonprofit have left for donations? How much money does the nonprofit have left for donations? I have some questions on multiplying fractions. We can do a dividing fractions problem right after that. And then I think I have one on subtracting fractions. Okay, any responses? I know this one may take a little bit of time. Okay. Any answers, responses? Third and fourth graders? So let me go ahead and draw our table. We have a plus here, we have a minus. So on the left hand side, this is the amount of money that we have, and this is the amount of money we're giving away. So the money coming in, the money given away. So let's see. Let's wait for about 30 more seconds and see what we have. And then I'll go ahead and show you how I think about these problems. Okay, let's go ahead and try this out. So a local nonprofit has a budget of $9,724.89. So let's see, we have 9,724. Okay, good try. And 89 cents. And then it contributed 3,644 and 80 cents to a woman's shelter, and also contributed 5,900, there's a comma here, $5,923.74 to a drug treatment center. So this is all the money that went out. So we're going to add all of this together. Okay, Lillian, I'll look at that. Give me a few minutes on this. So we're going to add all the money that has been given away. So 0 plus 4, we have 4. 8 plus 7, we have 15. So we're going to write 5 here and bring 1 up here. 1 plus 4, 5 plus 3, we have 8. 4 plus 2, we have 6. 9 plus 6, we have 15. So we're going to write 5 here and bring 1 up here. And then we have 1 plus 3, 4 plus 5, we have 9. So that means that we have $9,724.89 available, but we've given away $9,568.54. So let's go ahead and find out how much is left over. So this is going to give us $9,724.89 minus the amount that we gave away, $9,568.54. All right. So 9 minus 4, we have 5. 8 minus 5, we have 3. So 4 minus 8, we can't really do that. So we're going to come here and take 1, borrow 1 from 2. And so this left with 1 here. The one I borrow here becomes 10. I must add that to 4. So that is 14. 14 minus 8, we have 6. And then here, 1 minus 6, I can do that. So I'm going to come to 7, borrow 1, we're left with 6. And then this one I borrow is 10. 10 plus 1, we have 11. 11 minus 6, we have 5. And then 6 minus 5, we have 1. And then 9 minus 9, we have 0. So we can just ignore that. So at the end, the amount of money that is left over is $156.35. Good try, good try. I see someone got it right. Good job. Okay, so now we have some fractions. Every time I meet with the second to 7th graders, I'm going to have some fraction problems that we need to walk through. I want to make sure that you're very comfortable working with fractions. So here we have, okay, Dayo, good job. And I'm sure we'll have some time after, and then I'll address Lillian's question. Maybe after this, I can address that. Okay, that's a good question, actually. Okay, so let's go ahead and solve these fractions. Anyone have an answer before we go ahead and solve them? Okay, let's go ahead and look at these fractions together. Let's look at the first one. So we have 4 over 5 minus 1 over 4. So the first thing you always want to do with subtraction or addition of fractions is make sure you have a common denominator. Here we don't, so we need to find our common denominator. Here it's safe enough to just multiply 5 by 4, so that's going to give us 20. So what I now need to do is to find the equivalent fraction for each of these that has a denominator of 20. So what I now have to do is 4 over 5, I need to multiply 5 by a number to get to 20. So I multiply 5 by 4. So I'm going to also multiply 4 by 4. 4 multiplied by 4 is 16. 5 multiplied by 4 is 20. So 1 over 4, we do exactly the same thing. So I have 4 here. I multiply 4 by 5 to get to 20. So I multiply 1 by 5. So this is going to give me 5 over 20. So now we will then replace each of these fractions with their new equivalent fractions. So this is going to be 16 over 20 minus 5 over 20. So we keep the denominator the same because we have a common denominator, and now we subtract the numerators. So 16 minus 5 is 11, and then our denominator is 20. Now when you get to this point, you have to ask yourself, do these two numbers have a common factor? So is there a number that can divide into each of the numerator and denominator without a remainder? The answer is no, because this is a prime number. So you cannot have a common factor here. So this is going to give us 11 over 20. Now the next one we have is a multiplication. Whenever you have to multiply or divide fractions, you always have to write them in as either proper fractions or improper fractions. Here we have 2/3 is a proper fraction. And then we have here we have a mixed number, which is 1/4. We now have to write this as an improper fraction. So to do that, I multiply 1 by 5, which is going to give me 5, and then I add 4 to that. So my new numerator is 9, and my denominator is 5. Now that we get to this point, we can actually multiply across. So 2 multiplied by 9 is 18. 3 multiplied by 5 is 15. So now you can, now that you get to this point, you have to figure out if you have a common factor. We have a common factor of 3. So you see where understanding your rules of divisibility helps, because all you have to do is, if you don't know your multiplication table that well, you can at least try to say 1 plus 5 is 6. 6 divided by 3. 6 is a multiple of 3, or you can divide 6 by 3. So that means 3 is a factor here, and then you can try that here. You get 9. 9 is because 9 can be divided by 3, then 3 is a factor. So there are lots of different ways that it becomes useful. So 18 divided by 3 is 6, and 15 divided by 3 is 5. So we have 6 over 5, or we can convert this to a mixed number, 6 divided by 5. We have one group of 5 and 6, 1 multiplied by 5. I have 5, subtract, I have 1. So this is 6 over 5 is also the same as 1 whole number, 1 over 5. So that's the solution to this problem. And before we go ahead with the question, I want to address the question that Lillian asked. I think it's a good question. So I'm going to copy it onto the screen. Okay, this is the question here. Okay, this is the question that was sent. All right. Sally wants to watch her favorite TV show, which starts at 7 o'clock, but she has several things to do first. She needs to read 30 minutes, eat for 25 minutes, and clean her room for 15 minutes. What is the latest time she can start? What is the latest time she can start all these activities if she wants to be able to watch her show at 7 o'clock? Yes, go ahead and solve it. Go ahead and solve it. What is the latest time that she can start if she wants to make sure that she's able to watch her show at 7 o'clock? This is a good question. Thank you, Lillian, for sending it. Let's see, we'll give you about a minute and a half, 2 minutes. Well, that's too long. Let's try for about 1 extra minute and see the answers that we can get from. Okay, so I'm saying 450, I'm saying 550. Okay. Okay, let's see one more. Let's see if we can get one more response, and then we'll go ahead and start working on this question. This is a very interesting one. I want to see. Okay, so let's go ahead and start. 550, okay. When you have a question like this, the first thing you want to ask yourself is, how much time does she need to do all the activities that she has to do? So we're going to add 30 minutes and 25 minutes and 15 minutes. Okay, so let's add this up. So 0 plus 5 is 5 plus 5, we have 10. So we had 0, write 0 here and bring the 1 up here. 1 plus 3 is 4, 4 plus 2 is 6, 6 plus 1 is 7. So she needs 70 minutes. But when you're dealing with subtracting time, you always have to remember that you can have no more than 60 minutes on the minute side. So you're going to convert 70 to hours and minutes. So let's do that. 70 divided by 60. We have 1 here, 1 multiplied by 60. We have 60. I subtract and I'm left with 10. So now I have 7 o'clock, but I need to make sure that I get something done in 1 hour and 10 minutes. So we're going to do our subtraction. And when you're doing your subtraction, it's the same concept, only that you have to remember that every time you borrow 1, it represents 60. So we cannot subtract, so we have 0, 0 here. This is 0 minutes. Can you subtract 10 minutes from that? No, you can't do that. So I'm going to come over here and borrow 1. When I borrow 1, there's only 6 left over here. And the 1 I borrow actually is 1 hour. So that represents 60 minutes. So I'm going to have 60 minutes on the top up here. So 0 minus 0, we have 0. 6 minus 1, we have 5. And then 6 minus 1 here, we have 5. So the latest time she can actually start doing all of these activities, if she wants to get to her show at 7 o'clock, is 5:50 p.m. Good job. Everyone seemed to get that right. Good job. Thanks again for the question. That was a really good question. Okay. So 4th to 6th graders, we're looking at converting from ounces to pounds. A screw weighs 5 ounces. To build tables for a school, a carpenter needs 30 pounds of screws to complete the project. How many screws will be needed to complete this project? Well, we're going to do math today, Aaron. A screw weighs 5 pounds. To build tables for a school, a carpenter needs 30 pounds of screws to complete the project. How many screws will be needed to complete the project? How many screws will be needed to complete this project? Now you remember they're in different units. Let's look at, there are different units here. This is ounces and this is pounds. So the first thing you want to do is to you need to convert both of them to the same unit. Whichever way you want to go, convert both of them to the same unit. Okay, let's see. Let's wait for like a minute and see what anyone is able to come up with. Let's see if there are any comments that I need to pay attention to. Also remember that you can ask any questions, math-related questions for your grades, that if there's something you want me to take a look at, if we have some time at the end of, if we have some time to accommodate it, I will accommodate it. Otherwise, I will also prioritize it for the next session we have. So let's see. Okay, so I think we've addressed all the questions so far. All right, any answers? Oh, 80. Okay, let's try. Let's see if you're right. So the question here is that a screw weighs 5 ounces. To build tables for a school, a carpenter needs 30 pounds of screws to complete the project. How many screws will be needed to complete the project? So we have two different units of measurement here. We have pounds and ounces. The easiest thing to do here is actually to convert your pounds to ounces. So how many ounces are in a pound? So you have 16 ounces in 1 pound, okay? Some will use LB, so that's another option. So you have 16 ounces in 1 pound. So I'm going to write it the other way so you can easily see it. So 1 pound is going to give me 16 ounces. So what about 30 pounds? 30 pounds is going to give me 16. What I like to do here is, if you look from here to here, all I do is multiply by 30. So I'm also going to multiply by 30 here. So this is 16 multiplied by 30. And so 16 multiplied by 30. The trick is, ignore the 0, multiply 16 by 3. So 16 multiplied by 3. Let's put the 3 here. Let's erase that. So 16 multiplied by 3, I have 6 multiplied by 3, I have 18. Write 8 here, bring 1 up here. 1 multiplied by 3, 3 plus 1, 4. So this is going to give me 480. So we now have 480 ounces of nails. So 1 screw is 5 ounces, but we have an unknown number of screws here. This is going to give us 480 ounces. The simplest thing to do here is just to divide. Divide 480 by 5. 480 divided by 5. 48 divided by 5, we have 9. 9 multiplied by 5, we have 45. We subtract, we have 3. We bring the 0 here, 30. 30 divided by 5, we have 6. 6 multiplied by 5, we have 30. So we're going to have 96 screws. So in other words, the carpenter needs 96 screws to complete the project of building tables. All right, this is going to be our last question before we go ahead and look at our puzzles. So we're looking at absolute value equations here. So solve this equation, we need to get the values of x that make this statement true. The values of x that make the statement true. The values of x that make the statement true. This for 6th and 7th graders. We'll wait for a few more minutes or seconds. Let's see if we get any responses from our 6th and 7th graders. Okay, Lillian, I can help you with that in a few minutes. I want to remind you all that every topic that we've covered, that we've covered here, and that I bring questions that I bring there, those topics have been. We have videos of those topics in our video library on our YouTube channel. So if you go there and you search in the YouTube channel, you will see a lot of these videos. And so I have the topics here, so you can always go back to this video and look for the topics, and then you can search. You can search the YouTube channel for videos of that sort. All right, 6th and 7th graders, where are you? All right, let's put about 20 more seconds on the clock, and then we'll go ahead and address this question. For this, I'm actually going to show you 2 different ways to do it. Yes, I think I will. I'll show you my preferred method, and I'll show you a method that most teachers actually use. And if we have some time, I'll explain to you why I don't like the other method. Okay, let's go ahead and start with this one. So we have absolute value of 2x minus 4 equal to 12. Now, the way I like to approach this is to always remember that when you're dealing with absolute values, you can have either a positive value in between the absolute signs or a negative value between the absolute signs. So what I'm going to do here is I'm going to put a positive sign here, and then this is 2x minus 4 equal to 12, and then I'm going to put a negative sign out here, 2x minus 4 equal to 12, and then we're going to try to solve this together. So we have a positive sign here, so you can just assume that there's a 1 in there, so it's going to be 2x minus 4 equal to 12. I'm going to add 4 to both sides. And then we have 2x, okay, that's good, Anna. 2x equal to 16. And then we divide by 2 here, so x equal to 8. So the first value of x is 8. Pay attention to the sign on the number, so we're always going to use the opposite signs. And then here, we're going to distribute the negative sign into the parentheses, so we're going to have negative 2x plus 4 equal to 12. And then we're going to subtract 4 from both sides. So negative 2x equal to 8. Now we divide both sides by negative 2. Divide both sides by negative 2. So x is equal to negative 4. Now the other approach that I see very common, actually I learned it that way too, but I noticed further on as I used this for inequalities, it didn't really, that approach didn't really help much. But here's the approach. A lot of teachers use it. So if this is what your teacher teaches, it's fine. You can use it. So let me show you the approach. So this stays the same actually. They don't do anything about this side of it. But the other thing they do is some teachers have this 2x minus 4 equal to negative 12. They put the negative out on the number out here instead of representing the negative on the value between the absolute value signs. So they put the negative out here, and then you add 4. You add 4 here, so you have 2x equal to negative 8. Divide by 2, divide by 2, x equal to negative 4. So you can see that you get the same result. The only place where it gets to be funny is when you're dealing with inequalities. There are some times where it doesn't work as well. So that's why I tend to just use this. I tend to use this approach because it's very consistent regardless of what you're doing. Okay, so now let's go ahead and do some of our puzzles for the day. Our puzzle for the day, the first one. Temidayo, what grade are you? What grade are you in right now? I'll tell you if this is a topic that is relevant to your grade. What is the missing value here? What is the missing value here? 4th grade. You most likely will not be doing this. I think this is a 5th grade topic. The one you're asking is mostly for 5th graders. I believe so. But if it's something you want us to look at, we can look at it for sure. Are you doing something in school that this topic is relevant to or is helpful for? Do you need this question as part of something you're working on? If it is, we can do that on Friday. Okay, let's finish the quizzes, and I think we may have, if we have enough time, right after that, I will show you how to do that. Okay, someone says 6. Anybody want to try this puzzle? There's a hint in the puzzle already. Okay, we have 5th grade, 3rd grade, 2nd grade. Yeah, good mix. All right, let's go ahead. Let's go ahead and try to show you. Let me show you what this is. The hint here is the plus sign, because all you're doing is you're adding above and adding below. So 9 plus 8 is 17. 11 plus 6 is 17. 15 plus 9 is 24. 12 plus 12 is 24. So let's see. 18 plus 17, that's going to give you 35. And then what is going to be? The missing number here is going to be 35 minus 11. 5 minus 1, 4. 3 minus 1, 2. So this is 24. So that's all this one. I try to put some hints in the puzzle just so you can see it. So it's going to be 24. All right, let's go to this one. What is the missing value? Good try, Simi. What is the missing value? I want you to pay attention to detail here. Pay attention to detail. Pay attention to detail here. Yeah, what is the value? It's going to be a number. What is going to be, what's the number that represents the missing value? Yeah, you're on the right track. You're on the right track. So each of the, okay. So I have 5 as an answer. Okay, let's try one more. Someone has 6, someone has 14, 18, 35. Okay, so good response, good try, good attempt on all for everyone here. I have 31 here. Okay, so there's some things you have to pay a lot of attention to get this one right. So I have, let me use a different color here so it can show. All right, let's use red, or should we use this? Okay, let's do this one here. So this is going to be 5. Oh, this is not a good color. This is 5, and then this is 5. Okay. Then here we have 3, 3, and 3. All right. Now we have a problem here. Well, not really a problem, but we have something that we need to pay attention to. We have 3 apples, but if you pay attention here, can you see this right here? This accounts for 3. So this is going to be 3 apples plus, I guess let's just call it an insect. 3 apples plus an insect is going to give us 30. So 3 apples plus an insect is going to give us 30. I subtract 3 here. So now we have 3a is 27 divided by 3. A is equal to 9. So the apple is 9. So this is going to be 9, 12, and 9. All right. So for this insect here, or larva, or whatever we want to call it, we call this 3. That is correct. Now let's look at this stem of leaf, this stem with leaves, or this piece of a stem, yeah, with some leaves. Look here, we have 5, 1, 2, 3, 4, 5 leaves. But what happens here? We have 1, 2, 3, 4, 5, 6. So if 5 leaves equal to 5 points, so 6 leaves will be 6 points. That's one part of it. Then we also have this larva right here. So 6 plus 3 is 9. And then minus, here we already know that this value is 12. So now we have 3 multiplied by 9 minus 12. Let's use our PEMDAS. So this is 27 minus 12, which is equal to 15. Perfect. All right, we have 4 minutes left. So I'm going to try something for 4 minutes. I think there's a question here that I'm going to just give some attention for 4 minutes and see how much we can get through. So 820 divided by 63. So one approach to take with this is you're going to ask yourself, how many groups of 63 do you get in 8? That's not going to happen. What about 82? So here's an approach that some use. 63 multiplied by 1 is 63. 63 multiplied by 2 is 126. So you can see that 82 is between 63 and 126. So we're going to have one group right here. 1 multiplied by 63 is 63. Now we're going to subtract. 12 minus, so let's do this. This is going to be 7. This is 12. 12 minus 3, we have 9. 7 minus 6, we have 1. And then we bring down our 0 right here. So we have 63 multiplied by 3. This is 189. 63 multiplied by 4. This is 252. So you can see here that 190 is between 189 and 252. So we're going to use the lower value here, which is 3. 3 multiplied by 63, we have 189. So we have a remainder of 1. So now what this is going to be, 820 divided by 63 is going to be, we're going to write it in two different ways. It's 13 remainder 1, or 13, if you want to write it as a fraction, 1 over 63. So that's what I'm going to actually do for Friday's session. I'm going to write a word problem that makes you do this, and let's see if you remember. So it's 13 remainder 1. It's actually not 0.1, it's remainder 1. If you convert this to a decimal, it's going to be 0.0 something. Okay. That's all I have for today. It's 1:58. Thank you all for coming by. Thanks for the hour. I always enjoy this time. Today was very lively. Thanks again, Lillian, for the question. That was a really, really good question. And I look forward to hanging out with you again on Friday. On Friday, we're going to have our 8 to 12 graders as well. And stay safe. Just do whatever you can to wash your hands. Just be very clean and keep your environment clean and all that you are told to do from your parents and from the local authorities. And never forget to pray for those who are suffering. Just pray for them. And I look forward to seeing you all again on Friday. And if you want to join tomorrow, you're also welcome. And look forward to seeing you all. And enjoy the rest of your week. Enjoy the rest of your day. And stay blessed. Thanks again, and bye for now. I enjoyed it too. It was fun.